Hey everybody, today we're going to be talking about scatter plots and trend lines. This is chapter 5, it is lesson 7. Scatter plots. So take a look at this graph that is over here. This is earthquake data. You can see that on the x-axis down here, I have the dates that the earthquake happened, the years that the earthquake happened. On the y-axis over here, you can see that I have the magnitude of the quake, the strength of the quake, all listed up here. So a scatter plot is a graph that displays two sets of data as ordered pairs. So here's my first set of data. My first set of data is down here. It's the date. It's the X line. And the Y line up here is the magnitude. That's two sets of data. 1, 2. It graphs those two sets of data as ordered pairs, as if, like for this dot right here, it would be as if it was, this is a 1922-ish year, that an earthquake happened that was 6.6 magnitude. So my ordered pair would be 1920, comma 6.6 for the ordered pair. Correlation. Once I have created a scatter plot, I may or may not see a correlation. I may or may not see what is called a trend line happen. If I see a trend line that goes steadily up like so, where I've got some that are a little bit off, but for the most part, it's really close, that as this one gets more and more, this one gets more and more. If I get a line that goes like this, we call that a positive correlation. For example, this could be the more that a student studies, the better grades they earn. That would be a positive correlation. A negative correlation would be here, where we start up right here and all of a sudden the trend line goes down with time. So for example, if I'm losing weight and I eat less calories, less calories, that maybe the trend line would go down. Trying to think of a really good example for the negative correlation. But there you go. It's when one of the variables decreases, my weight decreases as I go on with calorie restriction. Maybe that's the way to put it. Another thing that you might occur that actually probably is more common than positive or negative correlations is no correlation at all. When I take two pieces of data, it just is random. I would dare say that the earthquake data looks very random to me, except that there are very few. The stronger earthquakes tend to be less frequent, but at the same time, there's really no pattern of strength of earthquake by the date. So that looks like a no correlation to me. Let's try this type of exercise. You're going to have a chance to do two different graphs. So I'm going to grab my pencil and I'm going to choose a color. And here's my X value. It is the altitude. These are plane altitudes and outside temperature. So when the plane is at this altitude, the temperature just outside the plane is 59 degrees. Now, I can't just plot a point. I have to make sure that I have a plan in place first. Because if I were to say that this is 1 and this is 2, well, then I would have a problem, because I have to go all the way. My biggest value is 61, and I do not have 61 spaces. So I have to be able to spread out 61 down to 0.6. So I'm going to have to figure out how many lines I have and then try to figure out how to plot them between the lowest value, 0.6, and the highest value, 61.3. I would say that I have, trying to see here. So if I start with, I think probably the best way is to subtract. It looks like it's 61. I have how many lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have, if I take 60, maybe I should go 65. If I go 65, then if I stretch this one to 65, then this one will actually still be on the graph. If I do it to 60, then it would be over here. It'd be over here a little bit. All right, I'm going to go ahead and do 65 divided by 16. And that says about 4 for each line. So, and notice that when I counted 16, that I didn't count this one. I want this one to be 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It says it's 4 for each. So that means that this one is going to be 4, 8, 12, 16, you know what? I noticed that I'm noticing a mistake, so I'm going to go ahead and just redo. That needs to go. This needs to go. This needs to go. Those need to go. Let's try that one more time. The reason that I'm making a mistake is because I started with the y factors. These are the y numbers, so we want to make sure that they're on this line over here. So I have 4. Oh, wait a second. We want to make sure this is 16 for real. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is not. That's a good catch. So if it is 12, then I need to take this 65 and divide by 12. That'll give me 5 for each one. That'll be 5.5. I think that that'll be fine. I'm going to do 5 for each one. So let's call this one 5. We'll count out by 5s then. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Now I can tell you that means that I'm going to have one data term right here that is going to be off the graph a little bit. I think that'll be okay. All right, so then this one here, my range is 5,000. My lowest term is 0. My highest term is 5,000. And I have 16 lines. So I need to make sure that I divide out my 5,000 divided by 16 lines is 312 per. Now, I got to tell you that I can't count by 312, so I'm going to leave 312 on my calculator, and then I'm just going to count out by that on my calculator. 312 plus 312 is 624. I'm going to write sort of at an angle here so that it doesn't look like a steady stream of numbers, so that if I write at an angle, then it'll look like I have a start spot for them. The next one would be 936. $12, 48, 1560, 1872, 2184, my whole angle thing didn't work out. I'm kind of going up and down. 2496, 2808, 3120, 3432, 3740, 3744, 4056, 4056, almost done. 4368, 4680, 'and it looks like it comes out to be 4992. This will put one value, that last data statement, slightly off the graph over here. Alrighty, let's go through each one. 0 is my x value. 59 is my my y value. So I'm going to come up here, find 59. Looks like I'm right here. 500 is my x value. Find 500. 500 is about right here. And my y value is way up here, a little bit higher than the last one. And the next one is 1,000. So I'm going to find 1,000. 1,000 is about right here. And I'm going to find my 61.3, just a little bit over the 60. Then I'm going to find my 1500 spot, and I'm going to place the 55.5. Then I'm going to find the 2000 spot. I'm going to place the 41. Ooh, that's a big drop, y'all. Then I'm going to find the 2500 spot. 2500 is right after the line here. And that is 29.8. Wait, after the, yep, that's right, 29.8. So right below the 30 line. Then I'm going to find the 3500. Did I skip? Oh, I skipped one. The 3000 line. The 3000 line is over here. 3000 is about halfway between. And then we're going to go up to 29.9. This one's even closer to the 30 line. Then I'm going to go to the 3500 line. 35 is about right there. And then 18.1. Then with my 4000 line, my 4000 line, I'm going to go, it's right before that, and then I'm going to go to 26.2. And then my 4500 line is right here. It's about right there, and that would be 12.4. And my last one, 5,000, just after the line at 0.6. 0.6 is down here. Alrighty. What do you think? Here's the last step. Circle the relationship. Is there a positive correlation, a negative correlation, or no correlation? Can I draw a trend line through the points? I tend to think I can. I think I can draw a trend line that kind of goes like, about a line that is about in the middle of all of that data. It does look like the temperature decreases the higher the plane gets. So I would call that a negative correlation. All right, we have 2 more problems to do that are just like this, and we'll work on them maybe a little bit together, and I'll probably let you go on on at least one of the problems, maybe most of the second one. Alrighty, let's go ahead and get after it.